Alright, so we're going to look at 10-3 for about 3 days. It's going to take that long for the information to kind of sink into your brain. You should come tomorrow with a lot of questions. Make sure that you grade your homework. I probably won't have it posted until after 4 o'clock, somewhere between 4 and 5 o'clock. But I will have it up there, just be patient. Okay, so 10-3, solving quadratic. Equations by completing the square. So we have learned that not all quadratic equations are factorable, number one. But even some that are factorable still cross the x-axis. And so we have to have a way to come up with the exact place at which the parabola crosses the x-axis, even when something isn't factorable. So one of the methods that you're going to learn to use is called completing the square. Sometimes you'll get a nice happy answer, sometimes you're going to get an answer with a radical in it. And it uses perfect square trinomials. So it's something that you should be familiar with. So the reason why you had perfect square trinomial review the day before yesterday was for this reason. So let's review it again. Example 1, you're going to want to write yourself a lot of notes because this is a process. So just like graphing the parabolas was a process, none of which was terribly difficult except for maybe once in a while finding the vertex. What you found out if you had difficulty on yesterday's test was that you didn't know the process. So if you don't know the process for completing the square, again, you're going to find yourself in trouble. So you need to learn that process and study it. So solve by taking the square root. I'm going to give you baby steps to completing the square. So the problem I'm going to give you, well, I guess we'll add on to this by taking the square root of both sides. So the problem I'm giving you is x squared plus 6x plus 9 is equal to 5. So you're going to have some problems in your homework tonight that it's asking you to do this. What do you notice about this side? It appears to be a perfect square trinomial. Why do you think that? Your bookends, right? The x squared and the 9, your bookends are perfect squares, aren't they? And this is in the form of, we're going to try to see is in the form of a squared plus 2ab plus b squared. Remember, that's the perfect square trinomial is part of the factor pattern. How does that factor this trinomial, if this is truly in that pattern? What's the factor pattern for this? Not an x, but a plus b raised to the second power, right? Remember, the a's and the b's in your factor patterns are different from the a's and the b's in a quadratic equation. In other words, this a is not the same as ax squared plus bx. That's not the same b. Different a's and b's. There's only so many letters in the alphabet. All right, so we're looking for this to factor in this way. I have to test using, if you recall, 2ab, right? So that's my test. So step 1, you might want to put this off to the side. Step 1, test to see if the trinomial, I'm going to abbreviate, matches 2ab. Because if it does, it's a perfect square trinomial, and it's a lot easier to solve if we identify that. Otherwise, we'd have to subtract 5 from both sides, factor, and set those equal to each other, and it may or may not factor. So we're going to put in here 2 times a and b. What is a? Yeah, the square root of your bookends are a and b. So square root of x squared is x. Square root of 9 is 3. What's 2 times x times 3? 6x. Does it match? Don't worry about signs. It matches, right? So since it matches, it must factor in this form. So then this was step 1. So then step 2, once you identify that it matches, you are going to factor as one set of parentheses a plus b squared. Now this could be a minus in here, right? When is that a minus? When the middle term is a negative. So you've already found a and b right here. So the x goes here and the 3 goes here. This is a plus in the middle because our middle term is positive. So it's x plus 3 squared. What does it equal? 5. So don't forget that 5. So didn't you learn how to factor or how to solve these before? We've done these before, haven't we? What did you do to solve for both sides? Yeah, because I have a perfect square on the left, I can take the square root of both sides. Sometimes you're going to get a nice happy number, sometimes not. You won't here. So now take the square root. So now take the square root of both sides to solve. So when I take the square root of the thing with the variable, that's okay, but what do I have to remember to do when I take the square root of a number? Plus or minus. If you forget that, you're only going to end up with one answer, and we need 2. So the square root of x plus 3 squared is just plain x plus 3. Can I take the square root of 5? No. So remember, leave it as plus or minus the square root of 5. Then do you remember what we do to solve? Subtract 3 from both sides, but make sure you subtract that 3 in front of the plus minus. And so our final answer is x is equal to negative 3 plus or minus the square root of 5. You're welcome to leave your answer this way. What it really means is this. Remember, there's 2 answers. X is equal to negative 3 plus the square root of 5, or x is equal to negative 3 minus the square root of 5. That's where this problem is going to cross the x-axis. And if I run this through my calculator, and I take negative 3 plus the square root of 5, I actually run it through my calculator, I will get approximately negative 76 hundredths. So it's going to cross between what 2 integers? 0 and negative 1, right? Because it's negative. And then this is going to become negative 5.24. So these are the roots. What 2 integers is that between? Negative 5 and negative 6. So you would be expecting it to look between there. Now, am I going to expect you to go from here to here? No, not without a calculator. So that's not new, is it? What's going to happen is I'm going to give you a trinomial eventually that this is not a perfect square here. And then completing the square, we are going to manipulate this equation so that it is a perfect square, so that we can solve it this way. Okay? All right, so. What was that?
So, are we going to do more examples?
Yep. That's not the only one. I have several today. All right, so then example 2. You are to find the value of c, that's our constant in the quadratic, that makes x squared minus 12x plus c, and it could be a minus c for all I know, that makes this a perfect square. Trinomial. So, remember again that this is in the form of, this is the quadratic form of ax squared plus bx plus c. So we know a and we know b, but we have to find a perfect square for c such that the sum or the difference of its factors gives us 12. So we've come up with a plan. So in order to find c, write yourself a note over here. In order to find c, use the following. C is always equal to b, the coefficient of the x term, divided by 2, and then squared. If we take this and cut it in half and square it, because I want, remember, in a perfect square trinomial, the inner and the outer term are exactly alike. So if they are exactly alike to get negative 12, wouldn't I divide 12 by 2? Wouldn't I get negative 6 and negative 6? And then we're going to end up squaring that negative 6 to get 36. So in this case, c is equal to, so we're going to take our b, which, and you don't need to worry about the sign. If you want to put the negative in there, fine. But c will always turn out to be positive in a perfect square trinomial, won't it? C really isn't ever going to be negative, is it? Because there's no way that I can take a number times itself and get a negative answer. Because I'm always going to have, I'm always going to be multiplying two positives or two negatives, and that will always give me a positive c. So I wouldn't worry about the sign if I were you. This should turn out positive. So what's 12 divided by 2?
4.
12 divided by 2? 6 squared is 36. So just to prove to you that this works, we're going to rewrite that quadratic as x squared minus 12x plus 36. Does it match 2ab? I see a perfect square here, I see a perfect square here. Let's take the test of 2ab and see if it matches it. What's the square root of x squared? X, so that's a. What's the square root of 36? 6, that's your b, right? So what's 2 times x times 6? 12x. And it matches, right? So does this work? It does. All right, so we're going to use that process. So you try it yourself. So example 3.
Okay.
You're going to try this yourself. So same directions. As number 2 above. I'm going to give you 2 items here. So the first one is x squared plus 6x plus c, and the second one is x squared plus 5x plus c. And I might add that finding c this way using b over 2 squared only works when the coefficient in front of the squared term is 1. Sometimes you might get an ugly fraction, but you're still going to have a completed square. When you get an answer, share it with those around you. The answer to B will be uncomfortable. It will be a fraction. Do make sure that you divide and or reduce as much as possible before you square. So what did you get for A?
No, not there yet.
You're not there yet.
No, not.
Why not?
We're still working on the problem.
No, it's very quick. C is equal to B over 2 squared. B is 6, right? 6 divided by 2 is 3. 3 squared is 9. Now, if I were to replace this with 9, would it match to AB? Okay, what's A? X. What's B? This is 9. 3. What's X times 3? 3X times 2. It works, doesn't it? Question.
I don't have to show that.
That it works?
Yeah.
No. I'm just proving it to you. All right, so then B was a little bit more difficult, wasn't it? Watch what happens, or part B. Watch what happens when we run it through the process. So our coefficient here is 5. Is 5 divisible by 2? No. Can you reduce 5 halves? No. So we're just going to square it. Remember when you square a fraction, you square the numerator and the denominator. So what's 5 squared? 25, and 2 squared is 4. So C is 25 fourths. Ugly but true. Now I'm going to prove to you over here off to the side that it does work. If I took x squared plus 5x plus 25 fourths, does that match to AB? 2 times A times B. What's the square root of x squared? X. What's the square root of 25 fourths? Yeah, take the square root of the numerator and the square root of the denominator. So you get 5 halves. What happens when I multiply 2 to 5 halves? The 2's cancel, right? And you end up with 5 times x, which is 5x. Doesn't that match the middle term? So it does work. So we are going to create, manipulate, and make perfect square bookends that match our middle term. You might not like those bookends, but you still know how to take the square root of them and that kind of thing, and we're going to use them to our advantage. Yes?
What is the point of squaring it and
You'll see.
unsquaring it?
You'll see. Well, the point of unsquaring it, TJ, was to prove to you that what we just did worked.
I believe you.
All right. Okay. You believe. That's excellent. So now we're going to use it. Are you ready? Now, TJ, calm yourself down. Now you have all the tools you need to complete the square. Are you ready? All right. So we'll do 2 examples of completing the square. So example 4, you are to solve by completing the square. If I give you directions that say solve by completing the square and you solve by some other method, you will not get credit for that because I am checking and testing, do you know how to complete the square? All right, so here's your problem. X squared minus 18x plus 5 is equal to negative 12. Look at the left side where the whole quadratic is. Is that a perfect square trinomial? I have a perfect square here, but 5 is not. So what we're going to end up doing is we're going to move 5 out of there because it's not working for us. So your very first step when completing the square, if this does not make this a perfect square trinomial, you're going to move it. So step 1, get rid of the positive 5 by moving it algebraically. And we're going to actually put blanks, or you can even put boxes in there, because I want you to remember that we're going to have to do something. So we're going to subtract 5 from both sides. So this is step 1. Listen with your mouth closed. It'll be a lot easier. All right, so we end up with x squared minus 18x. Then I want you to put a plus blank equals negative 12 and negative 5 is negative 17, and then I want you to put a plus blank. You must have a plus blank or a box on the left and the right side, because we're going to complete the square. We're going to find c, just like I taught you to in the last problem. But if I just vicariously put c on the left, do I have an equal equation? No, because whatever I did to the left side, I have to do the right side, right? So then step 2 is going to be to find c using c equals b over 2 squared. So c is equal to Our b is 18, doesn't matter that it's negative. So, did you get 81? Right? 18 divided by 2 is 9. 9 squared is 81. So we're going to add a positive 81 to both sides. That maintains the equality of both sides. And now because I have found C, I don't have to test it. I know I have a perfect square trinomial because I found C. So I've created a perfect square trinomial. So step 3, this is step 2. Step 3 is to go ahead and factor it as a perfect square trinomial. So step 3 over here, factor the left side as a plus or minus b squared. So we have one set of parentheses squared equals, and we'll have something on the right side. So find the square root of your bookends. What's the square root of x squared? X. What goes in the middle? Middle term is negative, so a minus goes in the middle. What's the square root of 81? 9. Then what is negative 17 plus 81? It is 64. You will not always have a nice, lovely, perfect square over here, but this one just so happens to be one. Now, based on what we did in example 1, what are you going to do for your final step? Yep, so step 5, if I can pull that up there. Oh, sorry, step 4. I was just pretending. Take the square root of both sides. Remember, when you take that square root, I hear more talking than writing. When you take the square root of both sides, you have to do plus or minus to that number on the right. So then for step 4, what's the square root of this? X minus 9 equals plus or minus, can we take the square root of 64?
Yes.
In this case, it's 8, right? Then finish solving. Add 9 in front of the plus minus. And for step 5, your answer is x is equal to 9 plus or minus 8. Can I actually find out what that is? What's 9 plus 8? So one answer is 17. What's 9 minus 8? 1. So those are the places where x, or the parabola, crosses the x-axis. If I asked you to give me the zeros in ordered pair format, you would write 17, 0 and 1, 0, right? But we're just using completing the square to actually solve our quadratic. Now, does that mean that I could have factored this original? If I got nice, happy numbers, could I have factored this?
Yes.
Yeah, I would have added 12 to both sides, and I would have had 17. Are there any factors of 17 that add to give you 18? 1 and 17. And look at what we came up with down here. So there was another way to do this. All right, but if I tell you to solve by completing the square, you must solve by completing the square. All right, last problem. TJ, you can go sit outside anytime you want to. Your choice. We'll go back to the fact that it's so sad that you have a teacher that teaches. Sorry. Solved by... Oh, what? You can't see that. Come on now. Solved by completing the square. When a, the coefficient of your x squared term, does not equal 1. So I told you before that the only time that you can find c using b over 2 squared is when a is 1. The coefficient of x squared is 1. So what do we do when it's not? Here's what you do. There's only one extra step. So here we have 4h squared plus 25 equals 20h. This is all messed up, number 1. Tell me what's wrong here, other than that there's a 4 in front of the h. And don't let it bother you that there's h's. The h really is no different than what? X's, right? So I've got to throw in other variables in here other than x because you're going to see them. Chris? Speak up loud. Right. We have to move these two terms. So I'm going to go ahead and move the 20h to the left just to see if I have a perfect square trinomial. So we're going to subtract 20h and subtract 20h. So I end up with 4h squared, write it in descending order, minus 20h plus 25 is equal to 0. Now, technically you do have a perfect square trinomial here. Okay? What's the square root of this? 2h. What's the square root of that? 5. What's 2h times 5? 10h times 2. Because remember, it's 2ab. So it does match. But what do the directions say? By completing the square. So I will argue with you that if I have a coefficient here, because this one's going to get slightly ugly, I probably would use a different method. But if you're not given a choice, you have to use the method you're told. And you'll find by the time we're done with Unit 10, by the time you're done with Unit 10, you're going to have several choices available to you so that you can choose whatever you like best. But you have to experience all of them no matter what. All right, so having said that, you're going to take care of this 4 by divide all terms, which essentially means both sides, by 4, because I want to get rid of that coefficient that's in front of my square term. So I'm going to divide this by 4, this by 4, unfortunately the 25 by 4, and technically the 0 by 4. So now I end up with h squared minus 5h plus 4 doesn't go in there, 25 fourths equals 0. I actually don't like this problem at all because won't that work anyway? Yeah, it'll work. So, all right. I'll give you another one. We'll work on another one in a minute. So if this, so it does match, right? Just hold yourself still. One more time and you're out. Are you hearing me?
Yes.
This is your last chance. All right, so if I were to square this, what would I get? Or factor this, what would I get? H minus, right, because of the middle, what's this? 5 halves. Square root of 25 and square root of 4. When I take the square root of both sides, I still do plus or minus here. So I get an h minus 5 halves is equal to, what's the square root of 0? 0. Do I really have to do plus or minus 0? No. Solve for h, what are you going to do? Add 5 halves to both sides. So h, I only have one answer. What happens when I have one answer? What do you know about it? Isn't that the vertex then? Isn't the vertex 5 halves 0? If you only have one answer, that means your vertex is sitting on the x-axis. We're going to do one more quick one. One more quick one. Last one, example 6. This is your last example. It might be. It might be. It might be. Are we done? So this time we're going to have 3x squared minus 15x plus 4 equals 0. So what's one thing that's wrong? That's not a perfect square, and what else is wrong with that? If we were to complete the square, can you have a 3 there? No. So the first thing I'm going to do, though, is I am going to subtract the 4 from both sides, because I know I don't want it there, because it's not going to help me. So I've got a 3x squared minus 15x equals negative 4. Then I need to get rid of that 3. So what are you going to do to get rid of the 3? divide everything by 3. So we're going to get an uncomfortable answer over here, but we'll deal with it. So the 3 cancels out of here, and I get x squared minus 5x. Then I want you to put a plus blank here equals the negative 4/3 and plus blank. TJ, you're going to write or you're going to ignore? Because with your head turned towards the wall, you can't see what I'm doing. All right, so now you get to complete the square. So what are you going to do? C equals b divided by 2 squared. So your b is 5, right? What's 5/2 squared? 25/4. So we're going to add 25/4 here and 25/4 here. Now I've created a perfect square here, ugly though it is, right? How does that factor? One set of parentheses, what goes in the middle? Middle term is a negative. Find the square root of your bookends. What's the square root of x squared? X. What's the square root of 25/4? 5/2 equals. Then we have to add these together. Can we add them together the way they are? No. What is your least common denominator? 12. If you don't know how to find the least common denominator, couldn't you just multiply these two together? Couldn't you just essentially multiply this by this and that by that? It won't necessarily be your least common denominator, but it will get you where you need to go. So for this to be 12, this needs to be multiplied by 4, and this needs to be multiplied by 4. For this one to be 12, 4 needs to be multiplied by 3, so that needs to be multiplied by 3. So we end up with negative 16. I'm going to do this off to the side. Negative 16 over 12 plus 25 times 3 is 75 over 12. What is a negative 16 and a positive 75 going to give you? Positive 59 over 12, right? Then what are you going to do? Take the square root of both sides. Square root here plus or minus the square root here. So on the left, I get x minus 5/2, right? Equals, and this is about as hairy of a problem as you would get, plus or minus, can you take the square root of 59? No. What kind of number is that?
Prime.
It's prime. So I'm going to split this up, square root of 59 over the square root of 12. Can you have a square root in the denominator? No. Can I simplify that? Yes. So off to the side, I'm going to rationalize this and simplify it. So off to the side over here, we've got the square root of 59 over the square root of, isn't 12 2 times 2 times 3? So what can I pull out? A set of 2's. So I really have the square root of 59 over 2 rad 3. How do you rationalize? Multiply just a rad 3. I don't need to multiply by the 2 because that can be in the denominator, just not the radical 3. So then 59 times 3, what is that? $177 over, what's radical 3 times radical 3? 9, not 9, 3. What's 3 times 2? 6, okay. So I finally have x minus 5/2 equals plus or minus the square root of 177 over 6. We're almost there. You ready? Last step, what are you going to do? Add the 5/2. Don't let the fractions bother you. And you're going to add right in front of that plus or minus. Let's see what we have left over. X equals 5/2 plus or minus the square root of 177 over 6. You do have to combine that into one fraction. What's the LCD of that fraction? Can't you turn 2 into 6? So multiply that by 3 and that by 3. You end up with 15 over 6 plus or minus the square root of 177 over 6. Now that they have the same denominator, can't you combine their numerators? Are these like terms? No. So your very final answer is 15 plus or minus the square root of 177, all of that over 6. That's going to bring us to our 10-4 lesson when we use something called the quadratic formula. You're going to have to get comfortable with answers that look like this. Now, having said this and gone through all of this, when I show you the quadratic formula, you will prefer to use a quadratic formula in a case like this versus completing the square. Yes? It's not negative b, it's the opposite of b. Everybody on YouTube is wrong. It's the opposite of b.
You're on
Yes.
YouTube, right?
I am on YouTube.
Yahoo's are wrong.
No, okay, everybody but me. How's that? All right, so
Everyone says.
let's look at some of your homework problems.